Alright, so now we're moving into lesson 2.5, and that's going to be dealing with switching between radicals and rational exponents. Our learning objective: students will convert between radicals and rational exponents. Alright, so as always, we're going to start off with a little warm-up here. So I would like you guys to go ahead and take a second to complete the warm-up. Okay, now that you've had time to look at the warm-up and try to complete it by yourselves, let's take a look at it. So question number 1 is just showing I have the base number is 1.05 and I'm multiplying them. So I know that I have to add those exponents together. So when I add those exponents together, I should get 3/12, or I should get 1.05 to the 1/4 power. Because you're taking 1/12 plus 1/12 plus 1/12. Alright, let me show you using the calculator just to help you out a little bit. Okay, so now that I have my calculator pulled up, I want to show you how you can use your TI-84 calculator to help you to add those fractions, because sometimes I know it's very difficult for us to add fractions. So let's take for an example the 1/12 plus the 1/12 plus the 1/12. Plus the 1/12. So in my calculator, in order to put fractions in, I have to use my parentheses, and as you can see, your parentheses is located above your 8 and 9 key. Alright, so what I'm going to do, I need to put the first fraction in. So I open parentheses and I put 1 divided by 12. Close my parentheses, and I got to add that to another open parentheses 1 divided by 12. Okay, because that's the fraction. And then I got to add that to another open parentheses 1 divided by 12, close parentheses. And then I hit enter in my calculator. And as you can see, I get 0.25. Now, notice here I said 3/12 or 1/4. Well, 1/4 is more simplified than the 3/12. The 3/12 is not simplified. So in the calculator, it's going to always normally produce a decimal number, but you can use your calculator to convert that decimal number to a fraction for you. So here at the top here of where this math key is, I'm going to hit this math key. Since this decimal is already in my calculator, I'm going to select math. And you'll see where it says fraction, decimal, or, you got some other things there, but we want to solely focus on the fraction or the decimal. Okay, so if I select 1, which is frac, F-A-R-C, it's going to ask me, well, do I want to take my answer, which is this, my previous answer, and do I want to turn that into a fraction? Well, I'm going to hit enter because that's exactly what I want to do. And as you can see, it took this decimal and it converted it into a fraction. So therefore, 1/12 plus 1/12 plus 1/12, it gives me 1/4 in its simplified form. So therefore, that is how I got my base number, because I know when I'm multiplying, the only thing I do is add these exponents together, and I have this 1/4. So it's 1.05 raised to the 1/4. All right. So for this one here, I have a power raised to a power, so I know that I have to multiply those two. Well, again, quite naturally, I'm going to use my calculator. So I'm going to do 1/12, which is a fraction, but it's okay, because we can handle fractions because we can use our calculator. So 1/12 times 6, hit enter, and I get 0.5. Well, most of you guys already know that 0.5 is just equivalent to 1/2. But if you didn't know, you can go to math and fraction, turn that decimal into a simplified fraction, and it should give you 1/2. So you should get 1.05 to the 1/2 power. All right, looking at this one here. So we got we have 1.05 raised to the negative 1/12 power. So remember, we have to invert that fraction to make, we have to invert this to make this a positive exponent. So we now just get 1 over 1.05, and that's raised to the positive 1/12 power. And here, still, I have the same bases that are being multiplied together. So automatically, I know I'm going to add those exponents. So when you add 2 plus 1/4, you should get 1.05 to the 5/2 power. And of course, you can put that in your calculator. And here you're dividing, so that means you subtract your exponents. So 2 minus 1/2, you're going to get 1.05 to the 3/2 power, okay? And you can do all those in your calculator. Okay, so now this question says, explain why this right here, 1.05 raised to the 1/12 power raised to another power, so automatically I know that I have to multiply those exponents to simplify it. Why is that equal to 1.05? Well, let's see. So if I take I see that 1.05 is my base number. So if I take the 1/12, which is the fraction, and I multiply that by just a whole number 12, you see that I get 1. So therefore, this becomes, there, I put that in there, I don't know why it left. All right, so we got a power raised to a power, so that means we multiply the exponents. When we multiply the exponents, we get 1. So therefore, 1.05 raised to the first power is just 1.05. They're the same exact thing. Okay, so now that we've had some time to kind of do a little reviewing, now today what we're going to do is we want to take a look at, well, first of all, what are rational exponents? So here we go, and we have y, the variable y, and it's raised to the 2/3 power, where a rational exponent is basically an exponent that is written as a fraction. That's all a rational exponent is, an exponent that's written as a fraction. And as you can see here, the fractional exponent here is 2/3. And we've been kind of working with them, but we've just never really given them a name. Okay, but now we know that they are rational exponents, or they're rational numbers. Okay, and the reason that they're rational numbers is because they're written as a fraction. All right, so how do we say this? We say y to the power of 2/3. All right. Now, what are radicals? And another word that I like to use for radicals that you guys might see are called roots. Okay, and here we have the third root of y. The third root of y, or sometimes you might hear people say the cube root of y. It's the same thing. All right, so this 3 here, we call that the root number or the index number. The symbol is our root symbol, okay? And then, of course, you have the radicand, which is just the number under the radical, okay? So we're not going to get too technical about that. Just know that there is a number that's underneath that radical, all right? And we say this by saying the third root of y. So if this number was 4, it would be the fourth root of whatever is under here. Or if it was 3, this little number up here was 3, or 8, it would be the 8th root of whatever is under there, okay? All right, so let's move on. So today, if you remember, our objective is just to kind of understand how we can switch between radical form, okay, and this is what and I have those mixed up. Let me just switch that real quick. Okay, it's good to know that you guys won't let a mistake go without letting me know, and I'm glad I caught that because that would have been very tragic. So anyway, so we've been talking about, we know what a rational exponent is, and we know what radicals are. Today, we're just going to take for granted that these two forms can be equal to each other. And so I can transfer one form to the other and the other form to the other. I can switch between the forms, okay? Because they're connected together. So we have, first of all, we have the rational exponent form to where you have a base number that's raised to a fractional exponent, and we've talked about that. And then we have what we call the radical, okay, and this is our square, this is where we have a square root, and we have that index number, that little small number that sits up top there of the radical or the root. And then we also have the whatever the number under the radical is, and we call that the radicand, but that's not important that we kind of remember that. But just know that that number under the radical is there, and that number is raised to an exponent, okay? There is some type of exponent that is there. And so now what I want to share with you is how we convert between the two. So for an example, let's use this. All right, so we can see you got the index number, you got this exponent that's on this base number under the radical, then you got the number that's under the radical, and then you have the root. So let's go back here. All right, so if I'm looking at this here and I want to switch from, let's say I want to take it from rational exponent form to radical form, I need to take my index or my bottom number. Okay, the bottom number of the fraction, that's going to be my index number. So that number is going to go on top of the radical. This number here is my base, so that goes underneath the radical. And this exponent here, or this number that's on top of this fraction, it's going to be the exponent on the number under the radical. Now, I know that was a whole lot, but let's look at some examples to kind of draw all of this together. So first of all, let's look at x raised to the power of 1/2. And what we're trying to do is write the given exponential expressions to radical form. So right now we can see that they're in rational exponent, okay? They're written as rational exponents. But how do I convert it to radical form or a root? Okay, so if I remember correctly, I have to use this bottom number of my exponent and this top number of my exponent. And I also use this base number of my exponent. So that's going to look like 2 is going to be my index number because it's under the denominator. Okay, it's in the denominator of this exponent here. So that's going to be my index. That's that little small number that sits on top of the radical. Okay, that's not saying 2 times the square root. That's just 2 root or the square root. So this is my index number. All right, and then this x goes under the radical, and that x is going to be raised to the power of 1. All right, which is the same thing as saying the square root of x. Okay, this is the square root of x, or root 2 of x or something like that. But typically we just say the square root of x. All right. Now here you see that there 2 is written, but here the 2 is not here. That's because you don't have to put a 2 here. You need to automatically know that if you see this symbol here written like this and there's no number in front of it, then automatically that the index number is 2. And you need to remember that, and that's something that you need to know. All right, so let's move on. All right, so look at another example. So this time I have 3x raised to the 2/3 power. Now, you might say that, oh, well, I'm going to just take the 3 and the x and put it under the radical. But you got to look at what's being raised to the exponent, because that's what's going to go in the radical. And here, because there is no parentheses here, the only thing that's being raised to the exponent is just the x. The x has this fractional exponent, not the 3. So therefore, when I simplify this, okay, it simplifies to, well, the exponent is not on the 3, so therefore this exponent is not affecting the 3. So that 3 doesn't go under the radical at all. Because this 3 is multiplying the x, we're still going to have it multiplying the x because the two forms are the same. They mean the same. We're just writing them different. Okay, so again, the 3 is going to stay on the outside. because it's not inside, or it doesn't involve, it's not being raised to the 2/3 power, only the x. So the only thing that we have to consider with moving is the x. So the x is going to go underneath the radical. And then my index number is going to be 3. And then my exponent is going to be 2. So that 2, that x is raised to the power of 2, which is under the radical. So I read this as 3 times the cube root of x squared. Okay, because that 3 is multiplying. Look, the 3 is multiplying. Look, the 3 is multiplying. So we're not changing anything. We're just changing how it looks. Let's look at another problem. So in this problem here, you'll notice that, look, the 2/3 is affecting both the 3 and the x. So what do you think that means? That, look, the 3 and the x get the exponent. Because it's almost like a power to a power. Because remember, you multiply. So the exponent here is 1. 1, you multiply. They're both raised to the 2/3 power. So what does that look like? Well, that means that both of these will go underneath this radical. The 3, they both have 3's. So it would be the cube root, okay, or the 3rd root of 3. Got to be squared, because that exponent there is 2. And the x also has to be squared, because that exponent is 2. Now, I can simplify that a little bit more by just 3 squared. Well, it's a number. I can put that in my calculator. Look, 3 and I squared, and it turns to 9. So instead of writing 3 squared, I'm just going to write 9. And so underneath the radical, I wrote 9x to the 2nd power. So if I were to read this entire thing, it would be the cube root of 9x to the 2nd power, or 9x squared. All right, so let's move on. All right, so now we want to kind of go backwards, okay? We want to write the given radical expressions to exponential form. So the first example that we're looking at is the square root of xy. So remember, this index number, the exponents that's on the things that are underneath the radical. So if I come over here, I write this fractional exponent. I already know it's going to be a fractional exponent because we're dealing with radicals if I were to rewrite them. Okay, so I know that the index number here is 2 because it's a square root. Even though it's not written, you should know that it's 2. All right, so this is going to be x to the 1/2 power, and then also y to the 1/2 power, because they're both under the radical. All right, so I can rewrite that by just grouping them together, okay, and just saying x and y grouped together is both raised to the 1/2 power, and they mean the same exact thing. All right, let's look at another example. So this time I have a negative cube root of x squared. Negative cube root, because this is our index number. So we got a negative cube root of x to the 2nd power. All right, so now how do I deal with that? The same exact way. All right, so we see what's under the radical. So the x is our base, the 2 is our exponent, and the 3 is our index number. So when I rewrite this, it is x raised to the 2/3 power. Now this negative out there, it just carries along, because guess what? The negative is not inside the radical, the negative is on the outside of the radical. So if you remember the example like the 3 that we had to deal with, this is kind of sort of similar to that 3, because we're not raising that negative. And if you want to think of this as a -1, you can, to try to help you to understand what just happened, okay? But this negative is not going to be affected by this 2/3, just the x, because that's what's under the radical. Okay, let's look at another example. So now look, we're squaring all of this stuff. because all of this stuff is raised to the second power. And so we're taking the cube root of all of this stuff and then we're squaring it. So let's consider what happens. All right, so if I were to rewrite this, I would take all of my stuff that's under my radical, which is a squared, b to the third, c to the fourth, and I'm going to raise that to the 2/3 power. Again, because this is my index number and this is my exponent, all of these things are under there. If I want to kind of simplify it or write it in a different way to show each of them individually, I could, but this is okay. This is the same thing. Could you distribute or could you multiply your exponents together? Yeah, I can multiply the 2/3 times the 4, the 2/3 times the 3, the 2/3 times the 2, and I could get another written expression that would still be equal to the same thing. All right, and let's one more example here. So we got the 7th root of m to the 3rd power times n to the 4th power. So how do you handle that? Same thing. All right, so you can take all of this that's under here, and it's all raised to the 1st power. There's nothing else out there. It's all raised to the 1st power. If there's no number out there, then you take all of this, what's under the radical, and you raise it to the 1st power, because anything is raised to the 1st power. So it becomes open parentheses because you're including all of this stuff in there. So the m to the 3rd power and the n to the 4th power is included, and it's going to be raised to the 1/7th power, okay? Because this is the exponent and this is the index number. Could you write this differently? Yes, you could, okay? Like I said, if you wanted to, you could go in there and multiply them together, and that would be equivalent of saying the same exact thing, but just writing this here lets me know that you understand how to turn it into exponential form from radical form. Okay, all right, so what I would like for you guys to do, I want you to take a look at these examples here, and you're going to go through, and you'll notice, like on the first one, they gave you a radical form. So I want you to write that in exponential form. Then here, they gave you the exponential form. I want you to write that in radical form. Here, they gave you the radical form. You're going to write that in exponential form, and same thing for the last one. And then tomorrow we'll come back together for a discussion.